Yeah. Uh, so okay. Yeah. So may I know like everybody has installed Jupyter Notebook?
Yes, sir.
Okay.
Yes, Santosh.
Oh, okay.
Yeah, yes.
Cool. Great. Yeah. So let's start. Today, actually, today the class is going to be interesting because we are going to see many new things, small things, but many new things we are going to see. So I can say the core Python we are going to start. So just a recap. Okay. So yesterday, what we have done? Yesterday, we have just seen the basic Python history we have seen, and we have seen how to print something and how to find out what we have seen. Can someone help me to recollect mainly what we have seen yesterday?
We have covered like basics of Python, like what's the history behind it, like who invented things like that. And apart from that, yeah, things like small things like how it's case sensitive, few errors regarding like the
Mhm.
integrated error, if I'm not wrong, like the space issues or minor errors. And apart from that, like a few coding tricks, like how to comment out things and how to code things,
Oh,
and what are the pre-reserved words. Like there are around 15 words, right? Like
okay.
which we cannot use. Yeah.
Got it. Got it. Yeah. Understood. So, fine. So with that, right, so let's jump to today's topic. So, yeah, so we are going to cover quite a few topics today. So, but I would suggest like wherever you are unable to follow or if you need further explanation, right? So please feel free to stop me and, but make it clarified because I'm again mentioning. Even the mistake I also made is because Python is so simple because what all we are going to study today, right? It seems very simple. There will not be any difficulty to understand. But because it is simple, we will make silly mistakes. They're like small pit holes. You will think, okay, I know this, I know that. Okay. So be alert and try to grasp things today. Okay. So let's start with that. So basically, just to tell you, there is I think currently we are working using Python 3 point some version. Okay, so earlier we used to have like Python 2 and 2 point its subsequent versions. The major difference is obviously there will be some performance increasing and there will be some fastness and there will be some optimization of the code, okay, between Python 2 and Python 3. But the major difference is, right, so in Python 2 uh, we don't need to give the parenthesis or this brackets to print something, okay, but now we need to, in Python 3 we need to definitely give these braces to print something. Without that it will not allow us to print anything. Okay, for example, if you see, if I just do print hello, it will give you parenthesis, missing parenthesis. Okay, did you mean to print, it is asking me because we are using Python 3 version. So that's fine. When I run this print hello, so we need to give the braces. So this there are like different theoretical differences between 2 and 3, like as I said, like computationally or the speed wise. Okay, but major practical difference is this. Okay, and there is one more difference I will be letting you know when I come touch that topic. Okay, so just remember this. After that, right, so we are going to see a topic of identifiers. Now what is identifier? So identifier is any variable we are going to create, right? So for example, any variable you can create, as I said yesterday. So you don't need to write anything before that. You can directly give a equal to 10 and it understands a is some value, it is you are giving over here. But quickly we need to understand there are some rules how you can define this name. Okay, this is an identifier or this variable. So but you cannot give everything, okay, because there should be some standards that followed. Okay, we are giving much freedom, but small restrictions are there. So that we need to understand. See, rules to define an identifier is the only allowed characters in Python are alphabet letters, either lowercase or uppercase, and digits 0 to 9 and underscore symbol. Okay, so in uh, identifier or variable, so whatever you are creating to assign a value, right? So see, whenever you are doing this, right, so always understand a equal to 10, that means a is a variable, okay, and 10 is a value. So you are always, and this is some operator you are trying to do, you are putting this value in this variable. Okay, so this is also called as identifier. Okay, so this combination we are going to see in depth, and we are going to see few interesting things in few minutes. But just understand this variable and value concept. So now we are just seeing what are the rules to define this identifier or variable. So you cannot give anything, but you just need to follow few rules. So the only allowed characters are alphabets and digits are underscore. What does that mean? So you need to give A to Z or 0 to 9 underscore. That's fine. But what if I give something else? So let's say I'm giving A at the rate, okay, 1. So it is saying cannot assign expression here. Okay, it will not allow to give something over there. So even if I give dot also, it is not going to allow. But underscore is allowed. Okay, so I can give underscore. So A underscore 1 is allowed. So it is printing A underscore 1. Okay, and identifier should not start with digit. Okay, identifier should not start with digit. That means obviously if I give 1 A, okay, if I say 1 meet equal to some 100, it is giving me error, invalid decimal literal. So you cannot start with a digit. Okay, and identifiers are case sensitive. Of course, Python language itself is a case sensitive. Case sensitive means not caps is treated different as small letters. That means if I say A equal to 10 and capital A equal to okay, so if I say A equal to 10, that does not mean I already gave capital A, because if I print capital A, it will say capital A is not defined. Okay, so A and capital A both are different. Okay, the complete Python language itself is a case sensitive. Wherever you see, so APPLE is different from APPLE, and that is different from APPLE. Okay, and this is different from PLE. So all these are different identifiers. Okay, even if you see as one single letter change, so that is treated as a different identifier, because Python is strictly case sensitive. Okay, so after that, next we are seeing alphabet. Yeah, so the rules are alphabet symbols, either upper or lower, identifier, underscore. And see, if identifier starts with underscore, right, then it indicates it's a private variable. For example, as because if you remember, underscore is allowed. Okay, and they did not mention where to use underscore. That means you can use it anywhere. That means you can use it at the beginning also. You can say underscore A equal to 10. That is also completely fine. Okay, so it will print underscore A. Okay, but a small rule is, if you're starting a variable with underscore, then it indicates it's a private. That means, when you're writing a lengthy code, so some variables are like little important, and they're little confidential, and they're little private, right? So then you can use these as underscore A. You can start them with underscore and your identifier. Let's say you are saying this is like the input. Okay, and you're saying underscore output. Let's say you're doing some testing, or you're writing some test scenarios, for example. You can say input output, then you can put underscore as in front of that, just to make sure, or uh, make the third person to understand, okay, these are a little important or private variables, and we should be a bit more cautious to use that. Okay, but the funny or the interesting thing is that nothing is going to change when you put underscore before that. Okay, so even if you don't put, or put, everything is considered as an same identifier, and Python gives same importance. But only for us, manually, for humans to make a thing little more important than others, we have decided to put underscore in front of that. Okay, so just to make sure that we are these all these words, all these identifiers are a bit private. And also if it is, if you're having two identifiers, right, sorry, two underscores between a identifier, that means it is strictly private. Okay, one underscore is private and two underscores when you are trying to give, so that means it is a strictly private, identifier. Okay, so you need to be more cautious using with that. And identifier should not start with digits. Yeah, we understood that. Okay, it should not start after, in between you can have some digits, but it should not start with a digit. Okay, and identifiers are case sensitive. Yeah, we cannot use reserved words as identifiers, right? So yesterday we have seen some reserved words, right? For example, true is a reserved word, right?
Capital D, sir. Capital
Oh,
T.
okay. Who's that? Siri?
Yes.
Okay, good. Yeah, so capital T. Capital T is a identifier. So you cannot assign a value. Okay, if you say cannot assign to true. Okay. Can I do it for false?
If it
Yeah.
is this capital, we can do, sir.
No, but can I put a value to this false word?
Yes, sir.
Okay. Yeah, it works because this is not a keyword because there is no capital F. So only when you put it capital, it turns. And by color also you can understand. When you put small, it is normal. But if I change it to capital, that means it is treating it as a keyword. Okay. So like that, you have around yesterday some around 30 plus keywords, right? So you cannot use any of them as a identifiers. And there is no length limit for Python identifiers, but recommended not to use too lengthy. Yeah. So as I said, you can give any length for the identifiers, but obviously we don't do that and it is not recommended. The dollar symbol is not allowed in Python. Okay, due to some coding standards. So dollar symbol is not allowed. Okay, so yeah, so as I said that any symbol is not allowed, but dollar symbol is actually they're not allow itself in anywhere in the identifier or coding part. Okay, so these are basic identifiers rules and regulations. So which will be you'll understand just when you start coding. So I think this is a good start to start with. Okay, so as you were saying, if your identifier starts with underscore symbol, then it's indicates it's private. If it starts with double underscore, then it indicates it's strongly a private identifier. Okay, so is this clear? Can you give me yes in the chat if we are good with this? Just in case if you are not okay to unmute and talk, you can just put yes. Okay.
Yeah, it's clear.
Okay. Fine. Cool. So next, yeah. So next, there are like few small basic functions. Okay, I would like to show you before we are going to further topics. Okay, there are few inbuilt functions. So one is type. Okay. Now coming to type, right? See, I'll give you a, as I said yesterday. Okay, yesterday, if you remember, we have multiple data types which we are going to see each of the example in few moments. But for example, we have integer. Okay, we have something called as string. Okay, and we have something called as float. Okay, different data types we have, right? But if it is simple, like if it is looks like 10, we understand okay it is an int. Okay, if it is something like data, we understand it belongs to string. Okay, if it is something like 10.5, we understand it as a float. Okay, but sometimes we don't know what is the data type of that particular identifier. Okay, that particular variable. So in that case, okay, not only variables, anything in future classes, whether it is a numpy array, whether it is a pandas data frame, anything, you can use type to understand what is its type, what is its data type. For example, I am giving okay x equal to, I'm giving 100. Okay, that's fine. So we understood okay x is equal to 100, x should definitely be integer, but how Python is understanding that? Okay, you just need to give type of x, it is giving you int. Okay, so type is very helpful and handy function, I would say. So you, and if you just for string, right? So I'm just telling you, for string, anything you put in quotes, okay, anything you put in quotes, that will be considered as a string. Okay, So these are like small points, but very very important points, I'm telling you, because once you start after this, right? So I will share you few links where you can practice Python extensively, where it will give you a very good grip on all these concepts, I would say. So there, the reason how I understood is, once I learned, so when I started attempting that, okay, we will you'll obviously understand the concepts, right? So you can tell what is type, id, print, etc. But when you start solving small problems, okay, you will make very very silly mistakes, so you will laugh at yourself. So that's the reason I'm saying, like like it will be like Python is like combination of small data points, not points, like small points, okay, where we need to be very careful. So for example, if you see anything in Python, if you put anything in quotes, that will act like a string. Okay, so I'm putting s equal to data, and if I type, sorry, I did not run this. Okay, so s is a string. So inside that, even if you put 100, okay, 100 is an integer, right? 100 is integer, but if you put in quotes, once you put in quotes, that will be considered as a string to the Python. Okay, so that is regarding the type. After that, yeah, I'll come to id, but after that there is print and input. So what is print? Print is, as you know, just to print something. Okay, just to know print something, you have we can use this print statement. Okay, so print statement is very simple, as you can see, but it is actually one of the very important function, I would say, because so when you're writing a lengthy code, sometimes let's say you're writing like 1 to 100 lines of code, you don't know like whether what's happening in between, right? So whether it has reached this particular step, whether it has reached this step or not, okay, it is giving you error, like what type of error it's giving you, sometimes you don't know, right? So for example, even yesterday itself, when I was working in my project, right? So I was not sure like what value I was getting. So I have declared a variable over here, some variable, okay. Okay, and I was building a model, and I was not sure whether it is actually taking that model value into the variable or not, right? So I was running multiple times, but later I remembered, okay, I can give a print statement. So then I have printed after creating that model, right? In this step, model is getting created, and in next step, I have inserted a print statement just to print that model and see what is the value that is giving. Then I got confirmed, okay, that is actually the model is getting created. Okay, with single print statement, you can get the you can track the programming language of what is the status, and like what all variables are getting created, and where till where it is working fine. Okay, so that's why we constantly use print statements wherein like wherever it is required. Okay, so in the start or wherever you are starting a new functionality or at the end, so print statements are simple but extremely important type of, and it's very obviously, as you can see, it's very simple to use. Just print it and that's it. And input. So input. So till now we have seen giving input to I mean directly declaring some variables. But if at all, if you want to take some input from user, right? So you can say as I said, x equal to input of enter a number. Okay, so now when I run this, it will ask for a number, and if I give 100, okay, now that 100 will be put into x, and if I print x, it is giving me 100. Okay, see, let me repeat. So when you input, that means we are telling Python interpreter that take the value from the user. So it is as I have shown you, I will show you again. So when I execute this, it is asking for a number input. So it is asking, hey, give me input, and what input? Enter a number. So you need to enter a number. Okay, so yeah, you need to enter a number. Yeah, see sometimes it gets stuck like this because I already entered a number. So I already executed this command, but before giving in entering any number, I have executed that again. So sometimes it will confuse the interpreter, and it will go into uh, a loop. Okay, so then we might need yeah. So I've interrupted. So now, yeah, as you can see, so I'm giving from 500. Okay, So now this 500 will be stored in X. Now if I print this X, it is 500. Okay. So now I'm giving 500, that is an integer. Okay, obviously. So now can anybody tell what will be the data type of X?
String.
Sorry?
Strings.
String. Okay. So because as you can see, input will always consider as a string data type. Okay, whatever value you give over here, even if you give integer also, even if you give float also, or even if you give normal string also, whatever you give, the input, when you are taking it from the input function, so Python automatically consider it as a string. Okay, so that's the reason, even though X I have inserted as 500, which is an integer, so obviously I expect that when I print type of X, that should be integer, but if I type it, you will get string. Okay, and it is also visible over here. Okay, so now if you just even if you give any value, so okay, even if you give string or integer or float, any value you give through input, that will be considered as a string. If you just want to convert that into int, you can just put a int. Okay, you can just convert like this. And now if you 500, and if you print, you will get int. Okay, so this is just called as typecasting, which we are going to see in next sections. But just always remember one point: input value will always be string. If you're directly taking some value through input, that is going to be always string. And if you want to do some changes, like do some typecasting, you can do it by inserting int, float, or etc., whatever that is required in front of that. Okay, so that is one concept. So I think we are good till here, but next is actually one of the important concept. Okay, and very interesting concept, that's called immutability. Okay, see, there are like few points which makes Python stand out when compared to other programming languages, and immutability is one of those. Okay, so like most of the people, I think they they understand it, but I have my doubts. So like be alert. So this is okay. So I think this could be the one concept which can give you good grip on Python. Okay, so now what is immutability? Okay, so immutability, okay, there is a concept in Python that immutability is that if a value is assigned to a variable, okay, you cannot change that. Okay, so there are like two things: one is mutable and one is immutable. Okay, so you have one is mutable, second thing is immutable. Mutable means what? Changeable. Okay, in simple words, changeable, unchangeable. You can change this, you cannot change this. But what are we talking about changing and not changing? Okay, so see, if at all, that means there is a variable simply X. Okay, I am putting 100. Now, immutability means once you have assigned a particular value to this variable, okay, you cannot alter this value. You cannot alter this value from this memory location. Okay, that is a fundamental description of immutability. Okay, so we will go into depths, but I'm again repeating: immutability means once you have assigned a value, okay, to a particular variable, no matter what you do, you cannot change that particular value from that memory location. Okay, but now let's see. Before that, just to access the memory locations, right? Access the memory location. Okay, so ID, right? So I missed ID. So ID will tell you, I think you already know a few basics, like whatever you do, whatever we are doing here. Okay, let's say I'm using X, it should have some memory location. So okay, Python should store somewhere in the background, in the hard disk, somewhere in the memory chips. So it should allocate some memory location inside that, right? So when I'm saying X equal to 100, so obviously what does Python will understand? Okay, user has given X equal to 100. That means in the whole memory, okay, inside in the hard disk or wherever the RAM, in the whole hard memory location, memory space, it will take a particular memory location, okay, and it will name this memory location as X. Okay, the name of this memory location is X, and it is going to put this 100 inside that. Okay, 100 will stay here, and to call this 100, it will use the name X. That is the meaning of this X equal to 100. That means indirectly you are saying, hey, reserve a memory location inside the memory bank and put the value 100 into it and give a name X to that. Okay, that is the meaning of this. This is what we are doing indirectly. That is fine. But how to know what is the memory location that is allocated? Okay, what is the memory location that is allocated to this particular value? So that you can get it from ID of X is this. Okay, so the memory location, each block, so all these are memory locations, right? So everything you do, obviously that should store somewhere. Okay, so each of this block will have some ID. So this, but for this X equal to 100 in my system, this might be different from your system. Okay, because your memory storage will be different from my memory storage. Okay, but it will be somewhat this number. So this particular memory location number is this number. Okay, ending with 2096. 2096 is a memory location of 100. Okay, so now coming back to the immutability concept. Okay, now what I'm saying, immutability means once you create a value, okay, and that is stored in a particular memory location, you cannot change that whatever you are going to do. Okay, that is a statement. And how, and this is a statement, or you can say theory. And now we'll try to understand how this stands true, and also we will prove that how this is perfect. Okay, right. So because immutability is one concept, as I said, when you can discuss with someone like you to show that you know some concepts of Python, I think immutability will be one of them. Now, a simple question, a cross question will someone ask you is, see, you're saying, okay, you cannot change the value, right? But see, I'm easily changing that. Now X equal to 100, I'm printing X. Okay, so I got 100. Now X equal to 200, I'm printing X. Okay, and if I print X, I got 200. So obviously X changed from 100 to 200, right? X initially pointing to 100, now it is having the value 200. So how you can say that it is immutable, right? So it is changing clearly. So how you can say that it is immutable? Might be the question, a cross question to test your knowledge, right? So but I want to check. So are we on track? Did you understand like immutability basic definition?
Yes, sir.
Yeah, yes.
Okay, okay. Yeah. So now, as I said, for every value, so it will be yeah, for every value it will be stored in the memory location. So now, as I said, see, observe carefully. When X is equal to 100, a value, the memory location wherever this 2096 is there, right? In that 100 is kept, right? So according to immutability definition, the value over here in this memory location cannot be changed. That cannot be changed. So, but what, when you see X equal to 100, X is pointing to 100. Now X equal to 200, now X is pointing to 100. Okay, so if you think that the value has changed over here, then that is wrong, because if you see the ID of X now, it is different. As you can see, 305,296 302096. Okay, so that means what happened inside is, when you called X equal to 100, so it has took this 2096 memory location and it has kept X equal to 100. Okay, and now, and this is X is pointing to 2096. Okay, let me write this way. So X is pointing to 2096. Now, when I said X equal to 200, okay, when I said X equal to 200, so it is taking another memory location with 5296 memory location, and it is putting value 200. Okay, now X is pointing to this memory location. Okay, that does not mean the value in this memory location got changed. Okay, according to immutability concept, what was my statement? My statement is, once you assign a value to a particular memory location, that cannot be changed from that memory location. That means, in other words, once I put the 100 into this memory location 2096, whatever you do till the end of this session, 100 will always stay in this 2096 only. Okay, but if you, but that is a statement. So but if you are getting confused, like earlier x equal to 100 but now x equal to 200, the concept here is, earlier when I say x equal to 100, okay, the memory location of x is 2096. That means x is pointing to this memory location which is having 100. That is fine. But now when I say x equal to 200, that does not mean now this is becoming 200. Okay, that does not mean this is becoming 200, because if this becomes 200, then you can say, okay, this is not immutable, this is changeable, this is mutable, because earlier in 2096 I am having 100. Now in 2096, if I have 200, that means I'm able to change the value in the memory location. Okay, but now when I say x equal to 200, it is not changing here. As you can see, it is a new memory location ID. It is 305296. 5296 is a new memory location. Now x, instead of pointing to 2096 memory location, it is pointing to this memory location. Okay, when you call x, it is going to bring this value 200. Okay, but 100 remains unchanged because of the immutability concept. Okay, we'll see the examples. It will give you more depth to you. So I will show you. So x equal to 100. Okay, and y equal to 100. Okay, now what I'm doing print id of x and print id of y. Okay, x equal to 100, y equal to 100, print id of x, id of y. As you can see, there is a memory location which is ending with 2096. Initially you have created x, putting value 100. This value is x, value 100. Perfect. Now you are saying y equal to 100. Okay, when you are saying y equal to 100, because this is, you cannot change this value. Okay, because you cannot, once you have created a value, okay, you cannot change this value. When you are creating another variable y equal to 100 with the same value, okay, Python interpreter, what it will do, it will first check whether this 100 is already stored in some memory location or not. Because if I say a equal to 100, b equal to 100, like that till z equal to 100, okay, z equal to 100, like 26 memory locations, all of them value is 100. So if I unnecessarily allocate 26 different memory locations to store the same value 100, it is not efficient, right? Because any memory location is pointing to 100, anything will give you the same result. Then why to make use of 26 different locations? So instead of that, whenever there is an immutability concept, what it will do means, first x equal to 100, it is going to store 100 over here. Okay, after that, when you are trying to create a new variable with the same value, first it will check whether that value is already stored somewhere in the memory location or not. Okay, in our case, y equal to 100, yes, 100 is already stored in this memory location 2096, and currently x is pointing to this 2096. But now when you are saying y equal to 100, same value, so what it will do, it will also put y also to point to the same memory location, because it's the same value it is trying to accept. Both are 100. That's the reason, as you can see, both are having same memory location 2096, 2096. That means single memory location can be accessed by multiple variables. X is also pointing to this, y is also pointing to this. Okay, so and if you create one more z equal to 100 also, it will, you are going to have the same id memory location. Now interestingly, now what I will do, I will change the value of x. Okay, now x equal to 200 I'm saying. Okay, now x equal to 200. Now what I will do, I'll print x. Okay, and I'll also print id of x. Okay, and I will also print the ID of y and z. Okay, now as you can see, okay, earlier, yeah, so earlier when I created this, okay, when I created this, what was happening to the same 100, we are having x and y, both of them are pointing to same 100. Okay, x and y, xyz. Okay, uh let me take xyz 2096. For 2096, x y z, three are pointing to same memory location because the value is same 100. Okay, that's fine. Now what I did, x equal to 200 I did. Okay, x equal to 200, that means now the value of x is, okay, now x is, there is a 200. Now x is 200, that is why it's printing. But to check whether a new memory location is used for 200 or the existing this memory location is changed to 200, I don't know. Okay, if this is changed to 200, then this is not immutable. This is, then it becomes mutable because I'm changing the value in memory location. So I cannot say, hey, this is immutable. I cannot claim that. But instead of this, if it is still 100 only, okay, if it is still 100 only, but for 200, it has created, used another new memory location, and now x is pointing to this, whereas y and z remains unchanged, still pointing to this with the value 100, then we can claim that, hey, the memory location is not getting changed. Okay, a new memory is getting used and x is pointing to memory location. As you can see, x equal to 200. Okay, now if you see print of x is, this is print of x. As you can see, this is a different number, 305296. Okay, so this 5296 is a new memory location which x is pointing to because it is a new value. But whereas y and z, as you can see, they are still pointing to same memory location, 2096 which is the same thing, and they both have the same value. If I print y, it is 100. If I print z, it is 100. So y and z are still pointing to same memory location, which is unchanged. So the point you need to understand here is 2096 memory location, which is having 100, it cannot be changed. If you want to assign a new value, a new memory location will be assigned and the variable will point to that, but this 100 will always be assigned to this 2096. Similarly, this 200, now we have created x equal 200 and 5296 is memory location. So till you close or crash this notebook, 200 will always be assigned to 5296. In future, in let's say in 100th line, if you are creating a new variable called as some like input is a new variable, and it is taking the value of 200. So first interpreter will check whether there is already any memory location which is already having 200. Why to unnecessarily waste the memory location? So if it is yes, okay, it will check, okay, 5296 is having a memory location which is having 200. So instead of creating a new memory location, it will point this x to this. That means what? X, sorry, this input to this 5296. So in this case, x is already pointing to 5296. So x is pointing to 5296. Input will also point to 5296 because the value is 200 for both of them. Whereas y and z, whose value is 100, will still point to 2096. Okay. Is this clear? Are we on track? Okay, just tell me if you did follow this. I will tell it again, but make sure that you understand this. Okay, but I will show you one more. I will just do, so this is immutable. Okay, I will tell you what is mutable. Then you can understand two things, and then we can take a doubt if you didn't understand. Okay, so as I said, memory location cannot be changed. That is fine. That is immutability. But Python has like 14 data types. Okay, 14 data types. Okay, so as you can see, yeah, so these are the 14 data types of Python: int, float, complex, bool, etc. All this which we are going to see. In this, all of them are not immutable. Okay, only few of them are immutable. Other are mutable. Okay, other are mutable means other are changeable. Okay, other are mutable. For example, list. List is a mutable. That means you can change the list. How? See. Now you'll understand the difference. So here, yeah. So for example, I will show you. I'm saying some list L, okay, L1 is some list. How to declare a list? I will tell you once we start studying list, but just at the moment, if you put something in the square brackets, that will be created as list. Okay, if you put something in quotes, that is string. If you put something in this square brackets, that is list. Okay, I am saying you list, but how can you make sure that this is list? Can anyone just tell me or ping me how can you know that this is list? How to know that L1 is list?
Type of L1.
Okay, good. So type of L1 will give you list. So as you can see, this is also list. That is cool. Now I'm just erasing this. So L1 is list. Now what I'm doing, print of L1. It will just print L1. Next I'm printing ID of, print ID of L1. That is cool. So now see, observe carefully. When I say L1, first it will take a memory location, give the name L1, and address is, memory address is 2160, value is 123. Okay, list of 1 comma 2 comma 3. That is fine. Now what, according to immutability concept is more, what if you are able to change the value in this memory location, then it is mutable. If you are unable to change the value in memory location, it is immutable. Okay, the value in the memory location, not the value of the variable. Value of the variable can easily change. You assign a value, x is 200, x is 200, if x is 1000, x is 1000, right? That is, you are changing the value of the variable. Okay, that is not related, that is not what we are talking about the immutability. Changing the value at the memory location in the background, you should be able to change the value in this memory location, only then you can call that as a immutable. Okay, now if you see, L1 is 123, L1, print L1, that is fine. Now if I change the value of L1, L1 dot append, okay, there is a function in append of for list which we will be seeing. So I am changing the value of L1. Okay, so we are adding a new L1. So I am adding, let's say, appending 4, and then I have appended 4. After that I am printing L1. Okay, now L1 is 1234. Okay, same variable, I'm not changing the variable name. L1 123 earlier, now L1 is 1234. Okay, now if I print ID of L1, okay, so it is the same thing as you can see, 2160 2160. Can you see? That means earlier in this memory location, you are having 123, but now in the same memory location, you are having 1234. That means you are able to touch the value inside the memory location. So you are able to change it. That's why list is mutable, that is changeable. Okay, so if you just summarize, if you just see these two things parallelly, what I did, x equal to 100 I did in one case. Okay, then L1 equal to 123 I did. Okay, so there is some memory location. Okay, some memory location, what was that? Yeah, 5, some memory location, let's say 5296. So 52, no, what was the 2096? Okay, yeah. So see, so I'm just summarizing that the concept you will understand. So 2096 is a memory location that is used to store this 100. Okay, this 100 came here for x. After that, when I changed x to 200, you need to verify whether the value inside this memory location is changing or not. Is it changing? No. When I say x equal to 200, then the memory location is 5296. A new memory location is created called as 5296, and 200 is saved over here. But 100 always remained in the 2096 memory location only. When even the variable is changed to new value. But if you see here, L1, same L1, initially it is pointing to what? 2160. Okay, and value is 123. Okay, 1 comma 2 comma 3. Now when I change the same L1, like how I change the same x, here I'm changing the same L1. Now L1 is 1234. Okay, 1234. Now because list is mutable, okay, because list is mutable, it is going to change the value in the same memory location. It is not going to create a new memory location. It can go back and change the same memory location. As you can see, 2160, 2160. So it will append something. Okay. So this memory location can be changed. You can mutate it. You can, that's why list comes under mutable. You are able to change the memory location. If x is an integer, okay, so it is immutable. So this is the main concept of mutability or immutability. Now let me know like if you understood or if there are any doubts, but make sure that you really understood this concept, at least the basics. Okay, can you just tell me whether did you understand or if there is any slight doubt or confusion also? It's completely fine if you are getting a bit confused because it's a new concept, but just let me know if you understood this or not.
Immutable, is it like immutable is for all the rest of the data types except this linear?
No, I'm coming to that. Yeah, I will come to that. Yeah.
Okay.
Yeah, but apart from that, anybody understood?
And one more thing, like if what is the use of this immutability for integer? Like if say I am declaring x is 200 in one cell, okay, going further I am declaring it as x is 200 or something. I cannot use x is equals to 200 again, right? Because whenever I declare it with a new value as x is equals to 100, it will, whenever I like call x or redirect to x, it is going to take the US value which I gave, and it will not bring up the old value, right?
Correct.
So like what's the use of immutable concept for integer?
Yeah, see, when you are saying x equal to 100 and when you are saying x equal to 200, because you want the new value for the x to be 200, that's the reason we are assigning a new value, right? So if you want 100 to stay, why you will assign a new value as 200?
Okay. So this concept works basically if, let's say, I want to, use the same name, like the same variable name, maybe this will work, right?
No, not exactly. But see, the fundamental advantage of here is to save the memory, right?
Okay.
Because if you see in simple words, what is immutability? I'm saying you cannot change the value. Okay, one is you cannot change the value, and after that, if you keep on creating lot of variables, if a equal to 100, a new memory location is assigned. Now again, one more variable, same 100, another variable. Okay, I mean the memory location is assigned like that. If you are ending up using lot of memory locations pointing to same values, okay, so that is waste of storage and memory, right? So
Yeah.
to stop that, Python has introduced for some variables the immutability concept. That means once you create a value, okay, once you create a value, you cannot change that. Okay, you cannot change that. Post that, any new variable you are trying to create with the same value, they will point to the same thing. Okay, they will point to the same thing only for the immutable data types. Okay,
Okay.
because immutable data types you cannot create a new value, right? For immutable data types, as you can see, x equal to 100, y equal to 100, so both of them are pointing to the same thing because you cannot create a new variable, so you cannot unnecessarily waste the memory for immutable concepts. So you have no other option to point to the same memory location you need to point. So in a sense, it is helping you to effectively like optimize the storage, right? So if there is no immutability um, concept, then what will happen? So you are going to if let's for suppose if there is no immutability concept, so what happens? So you use x equal to 100, and in a lengthy code, let's say there are like 50 variables which are pointing to 100. Okay, 50 different variables which are pointing to same value 100. That means in memory location there will be 50 memory locations, 50 different memory locations, all of them are pointing to 100. So like that if you filter it out, you can find out the actual values are just 5. Okay, let's say some 100, 150 something. These are the actual values, but these are repeated, let's say 1,000 times. These are repeated. Okay. But if you don't have immutability concept, okay, then what happens? You can always change, and for each value, a new memory location will be assigned. So 1,000 memory locations will be utilized unnecessarily. But bringing the immutability concept, making a restriction that once you create a particular value you cannot change, it is automatically giving new feature that any new variable that you are going to create with the same value will point to the same memory location. So instead of this 1,000 memory locations, unique are only five. So only 5 memory locations will be used, and it will attach this immutability concept to this all this five memory locations, and it will say, hey, these 5 memory locations are immutable. Any new variable you are creating, if at all it is having the same value, I will point to one of these. I'm not going to create a new memory for those. Okay, I want to save the memory as a Python interpreter. Okay, so that is a background advantage of immutability.
Okay. Yeah.
Is it clear? Did you get that?
Yeah. Yes, Sandesh. It's
Okay.
clear. Yeah.
Yeah. So others, you understood the concept, right? Mohan, you got the concept?
Yes, Santosh, I got it.
Okay. Yeah. So there is, yeah. So there is one more example as I was, yes. Okay. So there is difference. There are two things. Okay. One is equal to, okay, this is a very small concept, but interesting concept. See, I'm saying a equal to 10. Okay. Now I'm saying a equal to 10, sorry, 10, and b equal to 10. Now if I say a double equal to b, it is true. See, they're like, and a is b, that is also true. Okay, so first I will print some examples and I will tell you. See, now let's say if L1 equal to 1, 2, 3, for example, and b, sorry, L2 equal to, okay, and L1 equal to true. Okay, and L1 is L2. Okay, false. See, this is a very important concept. As you can see, now you will understand. Nikla, for your question also, this will absolutely make it clear. As you can see, initially there are two things. A equal to B is one thing. A is B is another thing. A equal to B means you are checking the value of A is equal to value of B. A is B is memory location of A is equal to memory location of B. These are two different things. As I said, for anything, there will be, this is a variable for this memory location. This memory location will have a value, and the actual value inside this is another. Okay, there are three things. So when I say A equal to 10, okay, so this is A, the variable name is A, the value here is 10, and there will be some memory location. How you will get idea of A will give you that. Okay, now if you are having two variables, some B, it will also have some memory location, and it will have some value, let's say 20, and this 20 is the value. Now interestingly observe, when I say A equal to B, it will just check whether the value of A is equal to value of B. That means, in other words, it will check 10 equal to 20. This will check whether 10 equal to 20 or not. That is a function of equal to. Okay, sorry, double equal to. Double equal to. Equal to is going to assign a value. Okay, equal to is always going to assign. So there is double equal to. So double equal to will check whether the values are same. So double equal to is will check whether the value of A is equal to value of B. A is B means it will check whether the memory location of A is equal to memory location of B or not. Okay. A double equal to is value, A is memory location. Both are different. Now, important point is just to summarize what all we are studying from last 15 minutes, just to summarize, just because the value is same, just because you are having A equal to B, that does not mean A is B should also be true. how we are going to see. See, for example, you are having A equal to 10, B equal to 10, A equal to B. Okay, this double equal to is A equal to B, true, right? Because as you can see now, because obviously both are 10, by visual only we can say both are 10, both are same value, that's why it is 10. This is general what we see. Now when I'm saying A is B, it is giving me true. What does this mean? This means the memory locations are also same. So now if you see A हो गया, A B हो गया, and I'm putting value 10, I'm putting value 10. Okay, now A equal to B true, yeah, both are 10 10 true. A is B is also true, it is saying. That means the memory, I don't know what is the memory location of this, I don't know what is the memory location of this, but when I say A is B, when I'm getting true, I can be sure that both will be same memory location. How will I know that? I'll just come here, print ID of A, and I will come here, print ID of B. Both are same, as you can see, to 196. That means internally there are no two memory locations. There is only one memory location called as 9216, where where the value is 10, and any variable you are assigning a value 10, it will point here. So now A is pointing to this, B is also pointing to this. Okay, this is happening because A is integer, 10 is integer, and integer is a immutable. You cannot change the value inside. So that's the reason when it is not allowing you to change the value, okay, so it will also not allow you to unnecessarily create new values, because if you are if it is allowing, see, if it is allowing you to not change, okay, see, this is important point. It is, if it is not allowing you to change the value, and also if it is not restricting you to unnecessarily create the values, what happens? You will keep on creating new values for each and every variable, and according to immutability concept, you cannot change them. So you will end up creating a lot of mess, right? So that means if initially according to immutability concept, you cannot change the value, and after that, that is fine. Now, along with that, if it is not restricting you to create new values, what it will happen? You will create a value, you cannot change this. This is fixed. Again, you will create new variable, you cannot change this because of immutability. This is also fixed. Like that, you will keep on ending using lot of memory, and just because immutability, you cannot change them. So, lot of memory is unnecessarily gets logged. So that's the reason whenever you are having immutability concept, it will not allow you to create new memory locations if the value is same. So that's why both A equal to 10 and B equal to 10 will point to same memory location. Okay, after that, but interestingly, if you see for list, L1 equal to 123, L2 equal to 123. That means what? There is a memory location, name is L1, inside 123. Now there is memory location L2, name is 123. Okay, now L1 equal to L2, yeah, L1 equal to L2 is true. I'm getting true because obviously value is same. But if you see L1 is L2, false. Even though value is same, even though value is exactly same, 123 123, even though value is same, the memory location is different. Getting? Because list is not a immutable concept. List is mutable. That means you can create new memory locations for the same value. So if I just print ID of L1 and if I print ID of L2, see, both are different. So this is pointing to some 88, this is pointing to some 16. Even though both are using the same value, it is pointing to two different memory locations. Why? Because list is mutable. So Nicola, just to your previous question, this can happen. Same value is using two memory locations. Like that, if I create L3, L4, like that, if I create L1 lakh, okay, L1 lakh, and if I'm using the same value 123 123, what it will do? It will create 1 lakh memory locations all over the memory device inside, and it will use the same value 123, and that is absolutely like does not make sense, right? Because same value, why you want 100 different memory locations? You can point all of them to same memory location. right? Getting?
Yeah, yes.
Yeah. And there are only few data types which it has given this power to. For like integer, it is immutable. So that's why if you create the same value, it will point to same memory location. But for list, it has given that freedom. Because if you can change it, so obviously it will create two different memory locations. Okay, so that that's the reason you are seeing the memory locations are two different, because if you change one, it should not affect the other one. Okay, we will see that in detail. But I think this is a concept. I think from this it should be clear to you, as integer is pointing to same memory location for same value, but whereas a list, even though you are giving the same value, it is not using same memory, it is using two different memory. Okay, because list is immutable. And we'll just end the class with the question you have asked, Nikla. So along in this, right, so all of them are not immutable. There are only few data types which are immutable. Okay, so I will just mark them. So int is immutable, float is immutable, complex is immutable, bool is immutable, string is immutable. Okay, bytes is immutable. Okay, byte array is not, it is mutable. Okay, range is I would say it is completely immutable, you cannot change. And list is, as I said, list is mutable. Okay, and tuple is immutable, and list is again mutable. Frozen set is immutable. Okay, and dict is mutable. Okay, none is a different data, so it will not come under. So all these are immutable. Okay, you cannot change them once. Say, okay, but only byte array, list, set, dict, these are mutable. Okay, so what are the concept we have just studied, right? So that will apply to all these. I took an example of int, but for all these immutable like int, float, complex string, so all these things, those are immutable data types, and there are only few mutable data types where you can change. Just to summarize, immutable will use the same memory location, and once you have created a value in the memory location, you cannot change whatever you do. But mutable, you will create different memory locations for the same value, and you can easily go back and change the value. Okay, that is the difference between immutable and mutable. Yeah, I would say that's all for today. Tomorrow we are going to extensively see each of these data types, and we are going to see something called as typecasting also. Yeah, so any doubts, or are we good? Can you just give a thumbs up or say something?
No doubt, Santosh. It was very much clear.
Okay, yeah, so Karthik. Yeah, I suggest you can be interactive, because this is almost like because we are like very few members, this is almost like a personal, like one-on-one session. So you can be interactive, and you can hop in if there are any doubts. Yeah,
Sure.
Sirish and Meghana, yeah, it's we are good, or
Clear, sir.
okay, perfect. I think then we are good. Hope you enjoyed this class, and tomorrow we are going to see each one of these data types. And yeah, so actually the main Python, as I said, the backbone of the data types, and tomorrow we are going to see. Once we are done with the data types, right? So the other things will automatically flow. That will be obviously easy. Okay. Yeah. So I think that's all for today. So, but my suggestion is, see, as I said, that it might seem very simple, but since you already installed Jupyter Notebook, right? So just take it and just start playing with this, so that you don't need any other guidance for this. So you just create some value, you just play with id, you just play with ease, double equal to, you just experiment. So only then you will get some comfort level, and just see immutability concept. See, one thing is in class, right, obviously when I explain, it obviously seems you are understanding, and you'll also understand most of that. But if you retain it, just to retain it, right, you need to just practice. And same day, if you're able to practice, right, so you will have like 80 to 90% of retaining. So because it will be fresh in your mind. So just take few general examples and see the immutability concept. Try to challenge the immutability concept. That would be my suggestion. Okay, fine. So that's all for today. Take care. Bye.
Yeah. Thank you, Santosh. Thank you. Bye.
Yeah.
Yeah, thank you, Santosh. Bye.
Okay. Thanks. Bye.